Okay, Chapter 30, the magnetic field. So we are up to magnetism. We're going to set aside our discussion of the electric field for a moment, and we're now going to talk about magnetic fields, and we are going to start with maybe the most important concept, and I think kind of the fundamental question is, where does magnetism come from? So please make sure you annotate this in your notes. You have down that we attribute the existence of the magnetic field to the charge property of matter in motion. In other words, moving Qs, both protons, positive Qs, electrons, negative Qs, both give us, create magnetic fields. Okay, so that by far is the most important thing. Now, why is it that these moving Qs make magnetic fields? Well, the truth is we don't know. But that should not be that disconcerting to us, because we saw with electric fields, we said it was the charge property of matter itself, not moving, just the fact that there's a charge property of matter that we attribute the existence of the electric field to, right? F equals QE. So we're really doing the same thing and saying this is just the world we live in. This is what nature presents us. Now, we will study it in more detail, just like we generated the F equals QE equation. We're going to generate force equations for how it is that magnetic field lines move charged particles around. But for right now, let's just talk about some of what we see with magnetism in everyday life that we know about. Well, one thing we know about are permanent magnets, like those refrigerator magnets. And they are also called ferromagnets, and they are metals. So they are iron, nickel, cobalt, for example, are materials, metals that can have magnetism, and not all metals do. For example, aluminum cannot be magnetized. And we attribute the magnetic field of these permanent magnets to the movement of the electrons, not the protons, because the protons are locked in the lattice structure of the metal, but to the movement of the electrons in what we refer to as magnetic domains. And I visualize that, I think of that as all the electrons in this metal, this permanent magnet, kind of dancing a synchronized magnetic field dance. So they're spinning, they're moving in such a way that there's an additive property of the motion of these electrons, all lined up, again, dancing this magnetic domain dance to take all of the electrons that contribute to the magnetic field in this lattice structure of the magnet to make the observed magnetic field that we see. Now, the observed magnetic field that we see, we attribute conventions. So what we observe is that the magnetic field around a permanent magnet comes out of, again, by convention, the north pole of the magnet, and comes out of the north pole, wraps back around, all magnetic fields wrap back around on themselves, and go into the south pole of the magnet. And notice I did not say begins on north and ends on south. So the language we use is very important, because magnetic field lines do not have a definitive beginning point and end point. They come out of north, go into south, but we do not use the language, and you need to be precise with your language in physics in general, but now specifically with magnetism, do not say that they begin on north and end on south. They come out of north and go into south and go through the material. Now, the fact that we haven't introduced our mathematics or explained, how it is to really think about these mathematically, or why it's doing what it's doing in a more detailed sense, do not worry about it at this moment. So we have these magnetic domains where the electrons are dancing their magnetic dance, and also you may have dropped permanent magnets relative to these magnetic domain discussion, and have dropped the magnet and found that it's less magnetic. And if you disturb the electrons in those magnetic domains, that electron dance that they do, so we shake up, we bang around this magnet, you can actually demagnetize it to a large extent, because basically what you're doing is you're taking those synchronized electrons and now tilting them in other directions to have a less combined effect to make the magnetic field. Now, and we'll talk more about that in this unit later as well, when we understand better about how it is we should be thinking about the moving charges making these electric fields. The other type of magnet we encounter in everyday life is what is called the electromagnet. So if you've ever seen TV or the movies where they have the scrap yards where the big crane with the disc at the bottom, the operator turns on the power and the disc picks up the metal, it becomes magnetic, and then they crane it over to a different area and drop it by shutting off the current. Basically, what is going on in an electromagnet is the movement of the electrons by the flow of Q, again, current, within a coil. So electromagnet is a coil, and we'll understand the details more of this later, generating the same magnetic field profile that the permanent magnet generates. And again, we'll understand the details of how this happens more later, but it comes out of north into south, wraps around, and actually goes through the coil. Well, the last thing on this page, and really the annotations are all up top right here in this discussion, to introduce magnetic fields as coming from moving charges and having a north and south pole and not having beginning and end points, is the primary emphasis of this first page, but also to give you a historical perspective, and that's the last thing I have here for this lesson, and really nothing to annotate, but for you to read and see that it really was the ancient Greeks that first, and maybe even before that, observed that permanent magnets existed, and then wasn't up until around the 1600s, where we're going to pick up our discussion in our next lesson, where William Gilbert realized the Earth itself is a permanent magnet. So why is it important for you, just as a generally educated person, to understand something about magnetism? Well, you are living on a planet that is itself a magnet, and we are going to talk more about that in our second lesson.